today's CUGC with Connect, with Martin Zugec. We're going to be talking about how to break the cyber kill chain of ransomware, which is a big scary sounding title, but I know he's got a good set of information for us today about protecting us from ransomware and all of the cyber attacks that we've been seeing out there. Martin is a senior architect in security and automation at Citrix, and you might remember his name from the Synergy sessions. He presented this at Synergy, so if you missed it or you weren't able to go to Synergy, now's your chance to hear the session and ask questions live with Martin. But before I turn things over to him, I'm going to introduce today's moderator. He is Patrick Coble. He is the Nashville CUGC leader. He's a CTP, and you can follow him on Twitter at VDI Hacker. Patrick's going to keep an eye on all of your questions, so if you'll type those into the question panel in the GoToWebinar control panel, he'll keep an eye on those, and we'll either get to those during the session or some of them we may save to the end. It just depends on what your questions are. Patrick, would you like to say hello?
Hello, everyone. Hope y'all are all doing good, and I'm excited to do this presentation with Martin because I think it's very practical for a lot of people, and I think some people are going to learn some stuff they did not know before.
Excellent. Thank you, Patrick. All right, Martin, it's all you. Take it away.
Sounds good. Okay, everyone. Hope you are having a really good day today. So this presentation that I'm going to show you is pretty much focused on the idea of looking at one problem from two different perspectives. And what I'm going to do here is that I'm not going to talk about ransomware from perspective of the traditional enterprise security team. I'm going to talk a lot about how the other side, the dark side, looks like. So the best thing how to present to you this idea, in my experience, is to start talking about the Nigerian advanced thief road. So I'm pretty sure that all of us have seen some variation of this email, whether it's the first African astronaut or it's the Nigerian prince, Nigerian king. All of us seen email that's like this. It's you just read it and you think, I could just be so much better at being the bad guy. I could fix the grammar. I would not use phrases like dear Mr. Sir. I would make it more believable. I would say I'm from US, for example. I would use the logo of the bank. Why are they doing this? Like, they are not really smart, the bad guys. Like, they are not professional. Now, this is perspective of normal administrator. But what happens if we kind of switch the sides and we just look at this email from perspective of the bad guy? So to do that, let's do some quick math. Let's say that you are going to be responsible for writing the spam email that we are going to distribute. And let's say that you can be much better in, and you can achieve 10% success rate, which means 1 in 10 people is actually going to respond to this email. Then let's say that you will need to exchange with this person maybe 3 emails until he realizes that this is a scam or he sent the money your way. And each response is going to take you just 10 seconds, okay? That would mean, and I'm using the numbers from the botnet Knackers here, that you would need to spend over 80,000 hours every single day just responding to emails. And most probably, you are not really going to be more successful than using the first variation of email with African astronaut. So from the bad guy's perspective, this email is actually very smart because it's completely offline filtering that's filtering the potential victims for you. Only people that are probably going to fall victim that you can convince to send you the money are actually going to respond to this. So instead of getting millions of email every single day, you are going to get maybe tens or maybe hundreds, but there is a high probability that you are going to be successful with this. So this is the principle where I wanted to show you that looking at the same topic from two different perspectives can be completely different. So once you understand the attackers, you can be much better at preventing the security breaches and making your environment more secure, and more importantly, building defenses that really make sense. So this presentation is going to be divided into two different parts. First, I'm going to briefly talk about the state of security industry, and I'm going to talk about the state of security industry for the cyber criminals and also from perspective of the enterprise defenders or traditional cyber security teams. In the second part of this presentation, I'm going to specifically talk about ransomware. So the state of cybercrime security industry in 2018, June 21, because this is something that keeps changing all the time, is that attackers are much stronger, much more professional, and much better organized than ever before. The reason why we are seeing this trend is that almost all the security breaches are financially motivated. So this is the big change that we are seeing. And this is the reason why we started seeing these large-scale attacks in the last couple of years. We used to say that cybercrime is a really good business, and I don't think that's accurate. Cybercrime is no longer just business. Cybercrime is actually a really big economy. So we are not talking about separate businesses or business units. We are talking about interlinked economy with a very complex supply chain where, for example, software developers can be specialized only in small components. For example, if you have a look at the dark web, you can find thousands of marketplaces that are selling everything you can imagine. You can buy the full ready-to-use ransomware, or you can just buy small components. And this means that all the attackers are professional, and we can have people distributing ransomware that actually cannot code. They can just buy all the components and put them together like Lego. So for example, if you have a look at Wannacry, most people think about Wannacry as like one piece of code, one piece of software. But that's not a really good way how to look at all the ransomware strains that we are seeing. You want to think about Wannacry, or generally any ransomware, as the software that consists of multiple smaller pieces and multiple stages and multiple modules or components. So, for example, Wannacry was using the allegedly stolen exploit from NSA, Eternal Blue. For distribution, they didn't have their own distribution network. Instead, what they did is that they just paid for one of the existing botnets and hired some small part of it for a couple of hours or days. They don't really need to develop the command and control infrastructure. They can just buy it as existing professional module from one of the dark marketplaces. For encryption and decryption, again, they don't need to spend months building the code. They can just use one of the open source projects. And for extortions, for the payment, if they would be more professional, they would probably use the Bitcoin mixers or some of the professional companies that are specialized in this money transfer. Now, if you think that this is not really how it works, I will give you one number that might shock you. About 97% of the spam distributed worldwide, 97%, is actually coming from only 2 large botnets. So, as I said, it's not as every attacker needs to come up with his own tools and his own strategy and his own distribution. They are much more professional. So you actually have crime as a service. That's a real thing today. We are going to give this presentation to you, and in the link, I try to provide as many resources as possible. I would recommend to have a look at the ransomware economy report from 2017, where you can read more about how this underworld is actually organized, how they operate, what you can see there, and how it really works. So, long story short, the bad guys are financially motivated. There's a lot of money in this business for them to make, and they are much more professional than they used to be in the past. And this trend is probably not going to stop. It's only going to get worse. Now, if you have a look at the other side, if you have a look at defenders, in my opinion, defenders are weaker and are having big problems to keep up. I wrote a whole blog post called The Art of Cyberboy, talking about this topic. So in the next 5 years, we expect to have almost 2 million unfilled cybersecurity positions. This number in 2016 or 2017 was 1.4. It was increased to 1.8. And now there are talks that this is actually optimistic and it's going to be over 2 million cybersecurity positions, where it's not only a question of money, we just don't have people. About 70% of employers are planning to hire more cybersecurity experts. The problem is that the median salary today is already over $120,000. If you are, for example, a security software engineer, the median salary is over $200,000. So again, it's not only about throwing more money in this problem, it's about focusing on what really matters and implementing the effective strategies. What many vendors are going to tell you is that new emerging defensive technologies like artificial intelligence or machine learning are completely going to change this game, and you won't need people. You will just have one tool that can guarantee you complete security. I do believe that these technologies are going to change the cybersecurity field. I just don't believe it's going to be such a big game changer. One of the reasons is that we are seeing the bad guys actually using these technologies as well. So it's not about the idea that the attackers will do exactly what they are doing today and you will have the next generation of protection and you are done. It's just not how it works. We are also seeing a lot of vendors claiming to have AI and machine learning capabilities. But once you start asking more technical details, you realize it's just a marketing phrase and it's not really the real technology. So what is the real strategy that actually works in cybersecurity? We have one strategy that we've been pushing for a very long time. It's defense in depth or multi-layered security. And this is still the only proven defense strategy. You cannot have one tool that is going to solve all the security problems for you. You need to be much more flexible in your defenses. You need to have multiple tools. You need to make sure that the tools that you have are well integrated and working together. Effectively, what you need to do is, with the limited people that you have, you want to have kind of force multipliers. That's why all the good companies with good security strategies are looking into AI machine learning. That's for multiplier, but they are also looking into heavily into automation and integration as well. So long story short, attackers are getting stronger, defenders are getting weaker and are having problems to actually keep up. So let's have a look back at the ransomware sample that I was talking before. There is actually silver lining for us in here. As the attackers are becoming more standardized and they are using kind of or recycling the existing software components, what we need to do is that we need to start thinking about the ransomware not as one piece of code, but we need to start thinking about all the different components. And what we can do as a next step is, if we can kind of break or interrupt one link of this chain of attack, we actually stop the whole attack. This is actually what happened, for example, with the Wannacry. First variant of the Wannacry, we've been able to stop the command and control infrastructure. That means that the first variant was pretty much harmless. And you can only imagine if we wouldn't be able to do that, it would be much larger and it would have much bigger impact than it does. Another example of this is the the largest botnet, Knackers, it went down actually for about 2 or 3 weeks because there was the software bug in the new release that they've done. And the word spam distribution went down by about 70% during this period. So again, the important strategy here is we need to have multi-layered security, and we need to focus on each and every link of this chain so we can stop this attack. What we've done to kind of expand on this principle is that we introduce something that we are calling a geeky kill chain. What we are doing with the geeky kill chain is that we have a look at all the ransomware infections in a recent time, and we identified 5 stages that every single ransomware attack is going through. That's the recon, infection, command and control or call home, expansion, and extortion. As a next step for each of these stages, we try to find out the best defenses and the best solutions, how we could stop it at this stage. In the next part, in the second part of this presentation, that's actually what I'm going to do. I will take you through all of the stages. For every single one of them, I'm going to talk about what are the tools and techniques that attackers are using, and potentially what are the changes that we are seeing recently, kind of evolution of these attacks. Then I'm going to talk about the best strategies for defenders and how does Citrix fit on what kind of solutions Citrix can provide you with. So the first phase is reconnaissance, and the goal of this phase is target acquisition. We are pretty much seeing 2 common strategies here. The first one is spam. So the attackers are sending high volume of emails, which requires very little effort from them, but is also not very successful. Second one is more targeted. This is the spear phishing attack, which requires a lot more work from attackers. So the volume, of course, is lower, but success rate is also much higher. There are kind of different levels of the spear phishing. The top level that we are seeing is called whale phishing, which is specifically targeting executives. And you don't hear about it a lot, but that's extremely professionally done, and it's actually very hard to stop and recognize. Now, the scary thing is that we can expect to see hybrid attacks in very short future. The hybrid attack is combining the high volume of the spam together with much better targeting of the spear phishing. And what attackers are using here is artificial intelligence or machine learning. So there was an experiment done by some DEF CON researchers, I believe 2016 or 2017, where they built a bot that could look at your Twitter account. It could analyze it. It can understand who you are following, who's following you, what kind of tweets you are posting, what kind of tweets you are interested in. And it was actually able to create a tweet specifically for your account and post it. And what happened to them is that they achieved success rate of about 30%, which is a huge number. And even they are saying this was just an experiment. It was not financed. It was not too professionally done. They just wanted to try if this can be successful or not. So what can defenders do? Probably one of the best strategies here is to focus on user awareness, training, and education. You want to teach your users how to recognize the spear phishing attacks, and you want to do this on all the different levels. This is pretty much the recommendations that you always get for security. Focus on all the end users. It's not too effective, I would say, because there's always way in, but this is something that you have to do. Research is showing us that a person that clicks on the spear phishing emails is most probably going to do it again. So you also want to understand your end users and understand what is the probability that he's going to click on one of these emails again. Now, if you are looking for more infrastructure solution, then what I would recommend is to have a look at the reputation-based email and proxy filters. Reputation-based means using IP reputation and using systems that can detect and block compromised servers. To explain why this is important, I have some data from the Google. So Google is releasing something that's called transparency reports, and you can find it in the notes for this presentation. Based on transparency report, what we are seeing is that 90 to 95% of the attacks originates from the compromised websites. So if someone is attacking your company, it's probably not going to be domain imhacker.com or vdihacker.com, but it's more probably going to be grandmasbakery.com. So it's going to be a website that was completely fine and legit 1 hour ago, and now it's starting attacking your company. If you think about the large botnets, the largest one, the Knackers, is about 5 to 6 million compromised computers, if I remember correctly. You can understand that it's easy for attackers to come up with algorithms where one of these compromised machines will stop using the crypto mining, for example, and it's going to start attacking you for the next 60 minutes. Then it's going back to crypto mining again, and you are not going to see it for months. So using static defenses here, the blacklist, for example, is not effective at all. Instead, what you want to focus on is that you want to have much more dynamic defenses. You want to have something that is able to detect the website that has been compromised and can stop the traffic to it. So what Citrix is implementing here is we have NetScaler Secure Web Gateway, which is the forward proxy that includes the IP reputation functionality. So all the traffic that is going to the NetScaler Secure Web Gateway, we can check if that website has been compromised or not. And if it was, we can stop it right away. We also have the URL categorization, but that's more static. So again, you want to use IP reputation. The common question that I get is, how do you know that it has been compromised? So the secure web gateway is relying on data from a third party. So we are buying this from the company called Netstar, and Netstar is collecting this data from about 800 million endpoints or 800 million devices that are connecting to the internet. One recommendation that I always like to make here is that Secure Web Gateway by default is updating the database every 24 hours, which doesn't really make sense. So you want to change this default and you want to update it at least every 4 hours, if not more often. There is no reason why you should do this on a daily basis. Now, when I was talking before about these compromised websites, the average lifespan of the website that is attacking you is between 4 to 8 hours. That's the average. Usually it's shorter. It's more like 2 to 4 hours. So again, having static blacklist of the known bad sites is not going to help you. Having the blacklist that's updated weekly or on a daily basis is also not going to help you. You definitely want to have something that's just much more flexible, and it's going to be updated on a more regular basis. Now, the next stage of attack is called infection. And the goal for the attacker is to get a foothold on your network. It's to infect the first machine that is available. So what attackers are doing here is that they are using zero-day exploits, if possible. That's kind of the best strategy for them. And they are also trying to be very, I would say, sneaky. They don't want to be detected at this stage. What we are seeing is that there is increase in the steganography. So they are hiding the code inside the JPEG or PNG file inside the picture itself, which is, I don't remember ever seeing this being blocked. They are looking for the more unique techniques that can be done. For example, the double kill that we've been looking at recently It's using the VB script engine that's actually triggered by the RTF document. So it's not the VBS file that you easily block on your email gateway. We are seeing new kind of attacks that are using the IQY extension for Office that nobody even knew that's being used. So they are really trying to hide the malicious payload, and they are getting much better at it. And again, it really helps to understand we are talking about cybercrime economy. And if I'm planning as a professional to launch the ransomware campaign, and I expect it can bring me back $1 or $2 million, I don't really mind investing a bit into it and paying for the new exploits or making it more professional. So for example, what you are seeing on the right side is the official marketplace. So this is not from the black market, this is official marketplace, where you see that for a single exploit for Windows, it can cost up to $300,000. Once you extend this and you start thinking about more, let's say, mobile payloads, the cost of single exploit can go up to $1.5 million. So again, there is so much money into this business that the bad guys are willing to invest. They are willing to make investments. They are looking at the return of investments, for example, for all of this. And for them, this first step is critical step how to get in your company. What defenders can do is, first of all, focus on patching. So we are talking a lot about the zero-day attacks and zero-day exploits, but most of the large-scale attacks that we are seeing are actually not using zero-day. The Wannacry was not using zero-day attack. The exploit that it was using, Eternal Blue, it was patched months before by Microsoft. So it's just about companies not patching all the systems. Many companies will say, we are behind with our patching because we cannot keep up. That's okay, but if that's your case, at least define the, I would say, 2 lanes systems for the patching. And anytime you have any patches that can help with browser exploitation, apply them as soon as possible. You don't really need to patch faster, you need to patch smarter. That's how I would kind of summarize it. In my opinion, this is also why when I like talking about the app layering. App layering can actually help you with all this patching, especially if you start using isolated and segmented environments. App layering is actually really awesome to have this kind of dynamic response. So next step is blocking executables at email gateway. This is pretty much de facto standard in security, but we are still seeing a lot of companies that are not doing it, surprisingly. Another one that should be common sense is disable all the macro-enabled documents or Office documents that you are using, or at least make sure that all of them are signed. This is also something that's not very common, and we see this as more and more common when attackers are trying to infect your machines. If you really have something that requires the macro, you can always take that and run it on a dedicated set of XenApp servers with Office, with requirement for the macro signatures and so on, but you should not have macro enabled on all of your workstations. Now, finally, this is kind of big change for everyone. Perimeter-based security just no longer works. The idea that everything outside is unsecure and everything inside your network is secure and to be trusted, this has been proven many and many times that this is just not good security. So if you want to prevent yourself from this kind of first initial infection, it's most important to understand how does this happening, where does this coming from? And 90+% of security breaches actually originates from email client or from web browsers. And this is not marketing BS. So what I did is that I went to the data breach investigations report and I went through all the numbers they have for analysis of about 50 million on the wire detections of the malware. And over 99% of the malware was actually sent by email or by the web. So what you want to focus your security on in this case is, how can I make sure that my email is secure and my browsers are secure and are completely isolated or separated from the sensitive data and from machines that I really care about. So this is where Citrix actually have a really good story, and it's the secure browser implementation or email architecture. And what we are doing here is that we are building dedicated farm of Zenab servers that are going to be responsible only for running the browser traffic, nothing else, or only emails, and again, nothing else. We designed this whole environment to be untrusted by default. So we are kind of reversing the traditional Zenab model where we trusted the data, whatever is on the right side, and the endpoints were always untrusted. Here we are doing the opposite. We are trusting the endpoints. They are the sensitive ones. And whatever we are accessing from this environment is always considered untrusted. The big advantage of this approach is, first of all, we are creating the security zone. Security zone means that we are able to secure this environment much, much better. For example, if you are using the VM app security or any kind of whitelisting or anti-FX permissions on the Zenab servers, it's much easier to implement them if you know that the only process that needs to be running is, for example, chrome.exe. You can be much better at securing this environment. Second thing that you can do is, because you are using application remoting that's running on the hypervisor, you can add more security elements that you could do on your normal workstation. So for example, you can implement the Chrome running on Linux, and you can have a special Linux appliance just for running this internet browser, which we can now host on the Zenab itself. So your users that are using Windows or thin clients can actually run the browser that's hosted on specialized Linux appliance that's running in your DMZ. Another thing that I always like to recommend is make sure that to use the proper network segmentation. So this is completely isolated, and the only connection to the endpoints is through the port 443, and that's all. Everything else is closed. One really good technology and very unique that Citrix actually have, and you can implement in this architecture, is called hypervisor introspection. It's available only on the Zen server with Bitdefender HVI. What hypervisor introspection is doing is that hypervisor itself provides access to the memory of all the virtual machines to Bitdefender appliance. And Bitdefender appliance is looking for techniques that attackers are using to manipulate with the memory. It's not looking for signatures. The big difference here is that we have tens of millions of new and unique signatures generating every single quarter. I actually found out the numbers in Q4 2017, it was over 60 million new samples that were introduced. Bitdefender, on the other hand, is looking for techniques, and there are only a dozen or so techniques that are being used. So huge advantage is Bitdefender doesn't need constant updates, and Bitdefender HVI can actually detect the zero-day attacks that were never even discovered before. It can stop them. Even though it doesn't know exactly what it is, it can know this memory manipulation that's happening here should not be allowed, and this virtual machine or this session should be killed immediately. To give you an example of what this means is the Eternal Blue, the exploit that was used by the Wannacry. As soon as it was documented first time, we tested it with HVI, and HVI would stop it right away. So even if Wannacry would never be patched and would never be announced, HVI was able to find it and stop it without knowing anything about this exploit. So the architecture that I'm showing you for the secure browser or email architecture, we call this secure zone where what you are doing is that you are building XenApp or XenDesktop environment as a buffer between untrusted and trusted sites, or kind of like to prevent the lateral movement of it. And again, if you think that 99% of the security breaches originates from the internet or the web browser or email client, this architecture is extremely powerful in preventing all these attacks. The next stage that we have, so is called command and control stage. This is where the first machine has been infected, and this machine is calling home for instructions, or it's uploading encryption keys, or it's just saying, I've been successfully able to infect this network, what should I do next? The attackers here are using highly decentralized architecture. So the way how this was visualized in the past was one hacker, and he would control 2 or 3 command servers, and they would control all the thousands of infected machines. That's not really how it works anymore, because this is more using like the peer-to-peer network, where every single compromised machine can act as command and control server. So it's highly decentralized. And the traffic, about 70% of the command and control traffic today is encrypted. And finally, they are using Tor for completely anonymous routing that cannot be easily blocked. So the command and control, this has changed a lot, and it's actually much harder to block it because it's much more dynamic. So in the past, you would be successful with blocking one URL or a few very well-known command and control servers. Today, it's much, much harder. That's, for example, when I was talking about Wannacry not being so professionally done. They use the old approach, which is how we stop the first variant, just by registering the domain they used for command and control server, and that would stop it right away. So for defenders, the recommendation here is very similar to the recon phase. Use the IP reputation based detection, use the secure web gateway to stop this traffic that's more dynamic. So one thing that you should remember here is that command and control servers are very hard to trace, very hard to block, very hard to detect. And what we are expecting in 2018 or 2019 is called hive nets, where imagine having the botnet with millions of compromised machines and kind of infuse it with artificial intelligence. So this large botnet will start planning and executing attacks without any help from the humans. Now, if you think this is more like a science fiction, again, think about the cybercrime security industry. You need only one person that is capable of programming and artificial intelligence. He can run this module and he can sell it to all the others. So again, it's not about every single attacker will need to be expert data scientist. No, it's just whoever comes first to the marketplace can get the biggest share of the market. So the architecture here again is very similar. We are using secure web gateway to detect the communication going from our secure zone to the command and control infrastructure. The only big difference here is that if you are able to detect the command and control communication, you already know for sure that your network has been compromised and something in there is trying to call home. So you should immediately hit the panic button and you should start recovering your environment and making sure that you can stop this before it starts expanding to all the other machines. Now, and that's the next stage that we are doing. So after first machine was infected, now this infection can spread to all machines that are reachable from this machine. And if you think about it, this is what was so unique about Wannacry. Before Wannacry, pretty much all the ransomware was infecting only endpoints, and that was it. What Wannacry is doing now is that it needs to infect only one machine, and then it can spread through the network automatically. So the result of this change, and this is big change actually for us, there are some things that are just different now. First one is that non-traditional devices are impacted as well. For example, in healthcare, you have many devices that are running on Windows, even though you don't know about them. The same applies, for example, for the IoT or industrial control systems. There are machines that are vulnerable that no one ever cared about patching, but with this automated expansion using new exploits, these machines are being targeted as well. So that's a big new change. The second big new change is that the attackers are not attacking specific machines, but they are pretty much attacking the whole companies. So for example, we are seeing brand new kind of services in security where there are companies that will specialize in negotiating with the attackers. They can, for example, reduce the ransom demands to half of what it was before, or they can provide you with the guidance telling you how exactly you should proceed if you decided to pay. So again, the biggest change here is it's not anymore about specific machines being attacked, it's more about the whole companies being attacked. Another technology that the attacker can use is so-called clone phishing. So this is type of phishing where usually legitimate email is modified for delivery of malicious payload. To show you, for example, how this algorithm can work, imagine that through this webinar, I've been able to infect the machines that you are using today. And I will have a look at your Outlook, and I will find out all the emails that you sent in last, let's say, 24 hours. I will filter out only emails that have some kind of Office attachment. And I will download the attachment. I'm going to rename it. So I'm going to add something like _version2 to it. And I'm going to send this email, forward it to all the people that were original recipients. And I'm just going to say something like, I find some mistakes, use this updated version instead. And I'm going to send it. Now, for programmer, this is actually a very simple piece of code or very simple attack to create. But if you think that you will receive this email, I would most probably open it because I'm receiving these emails every single day. I'm receiving tons of, I just made some changes. This is new version of this document. Okay, I know the person that is sending it to me. I know the context. I know that the attachment looked exactly like before, so it's valid email. I will just open it. And again, that's how this attack can spread across different network segments or even different companies. So what can defenders do? First big thing is they need to do everything they can to prevent lateral movement. And this is hard for many companies. Again, the idea is that perimeter-based security doesn't work. You cannot just have everything inside my network is wide open and it's trusted. You need to start thinking about everything that's on your network is potentially malicious. So you want to focus on the network segmentation. You want to make sure that you are applying the least privilege principle everywhere you can. The link in this presentation, I wrote the whole blog post talking about the recommended architecture and best practices to design it this way. The next thing that you definitely want to do is define and train emergency response scenario. So you want to know exactly what, who, and how is going to do when you start seeing this malware spreading through your network. And you want to make sure that these scenarios that you created before are not only good on the paper, but you can actually execute them. And you have all the controls and the tools and everything else that you need to execute them. So one thing to remember about this phase is it's already too late for prevention. You've been infected and the infection is spreading. And this is all about containment and control. So a lot of people are actually asking me, how is Citrix a security company, or what do you do for security? The way how I like to explain this is, in security, you have protection, you have visibility, and you have control, kind of like 3 core pillars of security. We are not really focused on the protection, think about antivirus, but we are mostly focused on the visibility and the control. So for example, recovering a well-managed Citrix environment, XenUp or XenDesktop, for example, is so much easier than trying to recover thousands of traditional workstations that have been infected and are not working anymore. So now think about the architecture that I was talking before. We call it Citrix Secure Zone. So the isolated virtualized environment that's by default designed to be untrusted. We are going to use the same approach to prevent the lateral movement. The change that I've done here is I added federation here. What federation would FAS effectively? What it would allow you to do is that in this environment, you could have completely separate and isolated Active Directory environment as well. And you could use FAS to provide completely seamless user experience. So the users will not even know that when they are running the published browser, that they are actually using completely different AD account, because they will never be asked to log on again or specify the password. So if the attacker is somehow able to infect this Citrix Secure Zone, and he will be able to escalate his privileges all the way to domain administrator, it is still just domain administrator of the isolated Active Directory, and he won't be able to use it to actually get out of this bubble and make sure that he can stay undetected on the network for months or weeks. The reason why this is also important is related to the kind of the staging of the attack. So the initial attack usually takes seconds or minutes, and on the average, then it takes about 170 days to discover security breach. If I remember correctly, about 30 days to actually remove the remains of the attack, and another 40 days to fully recover and patch all the holes and everything. So that's why you want any security breach to contain. And of course, ideally, what you want to do next is that even if the attacker is able to escape from this secure zone, isolated, he will just escape to another secure zone, another secure zone, and another secure zone. So that's the principle that we are using here. We take this secure zone and we apply it to all the applications and all the data, and segment it based on the sensitivity of the data. And we don't want all of this to run in one huge XenUp environment that's completely open. We want to isolate it, even though if we are using shared infrastructure for the management. So anytime when the attacker will end up in one of these secure zones and he needs to find a way how to get to the next zone, there is a chance and opportunity for you to detect that something is on your network and something is trying to infect or access all the other sensitive data. So that brings us to the final stage, and that's extortion. The goal of this stage is pretty much to get the money. This is the final stage. This is where the attackers will encrypt all the files, and they will ask you, send us this amount of money to this wallet, or else you will never see your data again. Now, especially in the smaller companies, what we are seeing is that the only defense from the ransomware are backups. That's the go-to, that's like the primary defense that they have. And I see this as a big problem. One of the reasons is that because these companies are getting much better at making sure they have backups of the data, the attackers are looking into other methods where the backups are completely useless to you. So the traditional encryption of files, the technique that we consider ransomware, is actually not the most common anymore. So what we are seeing, first one is the cryptojacking, and this is a huge thing. With cryptojacking, effectively, the attackers will infect your machines, and instead of doing like in-your-face, encrypt the files, may completely block the access to the workstation, they just use your machine for the crypto mining. That's all. Now, there's a lot of money in this business. So, for example, one of the groups of the cyber criminals made about $7 million in crypto mining in 6 months. The problem with crypto mining, of course, is that it's not so visible. Another approach that the attackers are doing now is extraction of sensitive data. So I attack your machine. I'm going to extract your pictures, for example, and then I'm going to ask you to pay for the ransom. And you tell me, I have the backup of the data, and I tell you, I don't care that you have backup. That's not what this is about. Backup is completely useless because I'm telling you, I already have your data. So this is another technique that's being used. What we are seeing, for example, or what we started seeing here is that, again, artificial intelligence and machine learning can be used to figure out which data is really sensitive and important. And instead of just uploading terabytes of data, we are seeing algorithms that are much better at detecting what is sensitive and what is not. The last type of attack that we are seeing, where the goal is the ransom and it is not traditional ransomware, is denial of access. So maybe this is something that you noticed or you heard about in March this year, 2018. We've seen the largest DDoS attack ever executed on GitHub. And it was peaking at about 1.7 terabit data, if I remember correctly. Now, what most people don't know is that this was not just normal denial of access attack, because inside the packets that were being sent or that were bashing on the GitHub, there was a message hidden saying, pay 50 Monero. That's like the most popular cryptocurrency for the attackers. It's not Bitcoin, usually it's Monero, which is more anonymous. Pay 50 Monero coins to this wallet, and we are going to stop this attack right away. So even though it was DDoS, effectively it was actually demanding the ransom to stop the attack. So what can defenders do here? First one is, this is pretty much the most common method today, just recover from backups, assuming that you have them. Another approach that's maybe even better is try decryption. So there is a website available where you upload one sample file that you have, and it's able to find out how that file was encrypted, and it can tell you, we can decrypt this automatically, which I've never used it, but I know about companies that were successful with this approach. Finally, for many companies, the only remaining options is just to pay ransom. And of course, what you are doing is that you are just fueling the fire and you are making this work. But unfortunately, that's often the last resort for you. What we are also seeing is that some companies will decide to pay ransom even if they have backups, simply because it's cheaper for them to pay the ransom and get decryption keys than shutting down the business for a few days just to recover everything from backup. Now, what you want to do here is, first of all, you need to patch the holes in your environment. So you need to get rid of the security breach, and then you want to recover the data that you have. Otherwise, you can end up in a situation where, for example, you pay the ransom and you are going to be infected again, which is not really working. So the one thing to remember here is backup should not be your only plan and strategy. Backups are not going to solve the modern ransomware, and they are definitely not going to be useful about the ransomware that's coming these days. So talking about this last stage, we are again using the secure zone concept for secure browsing. What we are adding few more components. So we are adding the shapefile here, for example. We So anytime when you need to download a file from this security zone to your endpoint, you download the file to shapefile, and shapefile is actually going to transfer it to your endpoints to the shapefile sync. The advantage of this is shapefile actually includes functionality where it can detect the ransomware attack. It can see that something started encrypting the files, and it can stop this for certain ransomware strains. Shapefile can be also used to recover the data, just roll back the changes and get the file before it was infected. We are doing the same thing here with the single image management, PVS or MCS. So if we know that this secure zone has been compromised, with very simple automation, you can just reset the whole secure zone back to the default settings. Same approach, if, for example, you need to recover it, it's very easy. You have centralized control, so you can shut down all machines. You can make sure that you apply the latest patches, distribute the new image, turn them on, and the infection of this secure zone is completely gone. We are also using the Secure Web Gateway, because Secure Web Gateway has support for the third-party DLP. So Secure Web Gateway can actually detect when the data is being extracted. Same case, by the way, with the shapefile. Shapefile can also detect the data extortion. And all around this, we are using Citrix Analytics, which is able to detect the unusual access to the sensitive data. It can detect, for example, unusual large volume upload of the data. It can work with the Secure Web Gateway. It supports all these products together. So it kind of, that's why it's across pretty much the whole portfolio. So to summarize it, ransomware and geeky kill chain, once you understand the kill chain of the ransomware, you can be much better at building the defenses against it. So once you understand what attackers are doing in each of these stages, it's just going to be so much easier for you to build defenses. And that's why I was talking during this presentation, that's why I was talking about all the different Citrix features and products and technologies that we have. Because once you realize this multi-layered security approach, it all makes a lot of sense. So if I show you this summary architecture that I'm using here, it might look overwhelming at first, but now once you understand all the little bits and pieces, this is much easier for you to understand why Citrix architecture, if implemented properly, can be a very good tool that you have to prevent against the current or the future ransomware attacks. So one final slide that I have for my presentation. These are my predictions, or this used to be my predictions for 2018-2019. Especially the first part is no longer prediction, because this is more like a daily reality now. Ransomware will start behaving more as APT, Advanced Persistent Threat. The idea being that instead of just doing one-time encryption of file, preventing access and demanding ransom, it's going to hijack your machines or your computers and use it to siphon resources using the cryptojacking from them. For this, I was predicting that we are going to see a lot more attacks on the Linux or high-performance servers, and also cloud hijacking. Again, today, this is reality. Cloud hijacking, the idea is with kind of the unlimited scaling of the cloud, if I can steal your credentials for Amazon or Azure, and I can build large amount of super powerful machines, then I can just use them to mine as much cryptocurrency as I can until you will receive invoice and realize what's happening. So again, ransomware will be much better hidden than it used to be in the past. The second prediction that I have, this is more for end of 2018 or beginning of 2019. We are going to see a lot more artificial intelligence and machine learning that are going to be used by the bad guys. It will be mostly hidden in better targeting of the spam and spear phishing, but we are probably going to see it being actively involved during the attacks as well. if you are interested in this topic, I can only recommend you the presentation from DEF CON called Weaponizing Machine Learning, with subtitled, really good subtitle, Humanity Was Overrated Anyway. And with this is the end of my webinar today. I hope that you learned something new, or you just enjoyed the presentation, and we can probably have a look at if we have any questions.
Yep, I'm looking through here. Yeah, probably the only question that I see that we haven't gone over is, if someone has a XenApp implementation and they're not planning to migrate to Citrix Cloud, what would you recommend that they do to secure their environment?
Yeah, that's actually a really good question. So a lot of people think that secure browsing is only the Citrix Cloud offering or service. No, it's actually the architecture that you can just use on premises as well. You have all the tools, you have all the experience, everything you need. We actually created the white paper with Bitdefender. How is it called? Securing secure browsing with Bitdefender. That's the name. And in that white paper, we not only explain how to implement this, we are also providing you with the tips and tricks and configuration and how to make the user experience seamless, because the last thing you want to do is publish multiple browsers to the end user.
Oh, definitely. Let's see what we got here. Let's see, can you explain further how ShareFile can be used to defend against ransomware events?
Yes, so ShareFile actually includes the functionality where once you start renaming the files, I believe it's looking for .log and few other known extensions. What it's going to do is that it's going to stop these changes from replicating to the storage zone, and it's going to quarantine the endpoints that have been responsible for doing this. Now, the next step is that potentially in very short future, if you are going to use Citrix Analytics, it can even do further steps, because this is just going to be one of the triggers for analytics. So it can, for example, block the user, it can send email to administrators, it can send email to user notifying him that this machine has tried to encrypt all the data that he has. This is for prevention. Again, ShareFile can be used for easy recovery of all the files, where you just say, this is the time when I was infected, revert everything before this date.
Perfect.
Do we have any other question?
That looks like it is it.
Okay, well, thank you, Martin. Thank you, Patrick. Before we close everything out, just want to let everyone know about our expanded user share webinar next Wednesday, June 27th from 11 a.m. to 2:30 p.m. Eastern Time. It'll be all focused on cloud. If you're looking to transition or even considering it and aren't there yet, that's fine. We have lots of great information for you. So I will throw in the chat window a link to that event for everyone here. And then if you'll go to the last slide of mine, Martin, I'll also let everyone know that you will receive an email from GoToWebinar tomorrow. It will have a link to the recording of today's presentation. It'll also have a link to the survey for today, which I've also stuck in the chat for you if you have time to do it really quickly. It's short, it's anonymous, it's for CUGC use only, and it helps us plan future webinar content and things like this. So Also go to mycugc.org and check out everything we have for you there. We've got lots of local groups that meet regularly, and you need to find your local group and find out where they're meeting, when they're meeting, and get involved. We've got more webinars, blog posts, and lots of forum threads for discussion, for questions, and everything all about Citrix. And finally, just a reminder to follow us on Twitter at mycugc. That's where we put out lots of announcements and information, and hope to see you out there as well. All right, thank you so much, Martin. That was a really great presentation. I hope everybody did learn something. I think I did. And thank you, Patrick.
Thank you. That's good.
All right, guys, have a great rest of your day. And to all of you out there, I hope you have a great day, and we'll see you at mycugc.org again soon. Bye, everyone.
Bye-bye.